Hi everyone, welcome back. In this video, I'll give an introduction to electrochemistry. So in first semester general chemistry, you learned about oxidation reduction reactions. And that's when one substance loses electrons and those electrons transfer to another substance. And so the mnemonic device that we commonly use is oil rig. And that is oxidation is a loss of electrons and reduction is a gain of electrons. So oil rig, oxidation is loss of electrons, reduction is gain of electrons. And I remember when I was a student and I was first learning this material, it was complicated, right? Oxidation reduction reactions are a little challenging to learn at first because seeing those electrons transferred is not something that is very tangible, right? And so the way that I like to teach this material is to show you some applications as to why understanding these oxidation reduction reactions is critical. So one of my favorite applications is talking about lightning. So I grew up in a small town in Texas and lived in Tornado Alley. And at the time when I was young, a movie called Twister came out and it starred Helen Hunt. And basically she was chasing tornadoes to study the science of them. And to be honest, if I hadn't become a chemistry professor, I think I would have studied weather and meteorology. I just think it's so fascinating. And lightning especially is all about transferring electrons. So I wanted to show you a cool video that I thought was interesting. I hope you find it interesting as well. And seeing electrons being transferred right in front of you. Like I said, this is a tangible application.
When observed with the naked eye, lightning appears to travel from the clouds directly to the ground. But recent advances in video camera technology reveal that the anatomy of lightning is much more complex. This is the U.S. Air Force Atmospheric Research Center in Colorado Springs. Here, Dr. Jeff McHargue is using a super slow-motion camera to capture lightning. To do this, he needs split-second timing.
Darn it. It's a lot like fishing. You just have to get lucky and get the lightning bolt inside your field of view.
Success is rare, but 2 years ago, McHargue hit the jackpot.
I was simply watching the lightning get closer and closer, and I kept recording it, and I didn't know what I had until I went back and reviewed it.
For the first time ever, Jeff had recorded the birth of a lightning bolt in super slow motion. When played back, it shows a flash of light dart out of a cloud and zigzag downward in roughly 50-yard segments. This first stage of lightning is called a stepped leader.
You can see the stepped leader coming down here, looking for ground, going back and forth. You can see the tortuous channel it is taking as it divides back and forth.
As this stepped leader gets close to the Earth, it has an extraordinary effect on objects on the ground. They respond to the strong electric field by growing positive streamers. These reach up anywhere between 3 and a few hundred feet above the ground, as seen in these rare photographs. Finally, when a stepped leader and a positive streamer meet, the electric charge can drain to Earth, resulting in the blinding flash of light we call lightning.
The entire field of view lights up. That's the main part of the lightning strike that your eye will catch.
The new generation of cameras has enabled scientists to record a strike that lasts just a fraction of a second and play it back over 200 times slower to analyze its detail. These super slow motion images show the stepped leader making a connection with the ground. The entire charge then drains from the cloud above, seen as a series of pulses. Using the latest camera technology, scientists are beginning to unravel the mysteries of lightning.
All right, so hopefully that was very interesting for you guys to watch. So let's talk about this again. So a positive streamer from the ground and a step leader from the sky. When they meet, the electric charge drains to the earth, resulting in a flash of light. And the negative charges in the clouds push the negative charges in the ground away, leaving those positive charges on the surface, those positive streamers. And so there's charging by induction, basically. And therefore, the lightning transfers electrons. From the atmosphere to the earth. And so that's what we will be discussing in these next series of lectures, just really understanding the transferring of electrons. Now we're going to be mainly focusing on chemical reactions, but I wanted to give you an application that was a little bit more fun. And also, like, if you've never been to Texas or just out in the Midwest where the sky's super flat, just very open wide, watching a lightning storm is just quite mesmerizing out there. So it's just really beautiful. And then hopefully if you do see a lightning and thunderstorm, then you'll think about electrochemistry and transferring of electrons. All right, so some of you may be wanting to become an electrical engineer. And maybe battery research is really interesting to you. So that will be the application I discuss at the very end of these series of videos. It's just focusing on different types of batteries that are out there. So the way they work is that substances are separated so that one end of the battery develops a positive charge, much like we saw with the lightning with the positive streamers. And the other end develops a negative charge. And then when a wire is connected, the electrons flow. From the negative end to the positive end. Creating an electric current. And so at the end of these series of videos, like I'll talk about dry cell batteries, or I'll talk about the batteries that are in your car, or even electric cars like in Tesla. So we'll talk a little bit about that at the very end, but it's all oxidation reduction reactions. And rather than say oxidation reduction over and over, we abbreviate it as redox. So when you hear redox reactions, that stands for oxidation reduction. Okay. Now, a lot of you want to go into biology or become doctors or physician assistants, and so you're going to take a lot of biology classes. So you will see redox reactions occur in biology too. All right, and that's why this is such a critical topic to cover in my class. So when you study cellular respiration, it is the oxidation of glucose to carbon dioxide and the reduction of oxygen to water to give us energy. So once again, if you want to take some more biology classes, cellular, molecular biology, and physiology, definitely going to be looking at some redox reactions occurring in the body. Also, many of you will take organic chemistry, and oxidation and reduction is covered extensively in that course. You'll learn about what makes a good oxidizing agent, like potassium permanganate or ozone, and what makes a good reducing agent, like lithium aluminum hydride. So you will always, if you continue on your path towards STEM, like redox is going to be so fundamental for you to understand, whether you go towards more engineering applications or if you go towards more biological applications. So make sure you get a good foundation in this class on this topic here. I know it's the end of the term soon, and so but just like I said, I can't emphasize enough for you to start mastering this material now so that you're set up for success in your future STEM courses. All right. Thank you all for watching, and I'll see you next time.